What's up, everybody? Hope you're having a great Wednesday. And today we are back with another live stream from Scale of Learning, all about SAT math. And it's pretty cool because we got a new SAT coming out very soon on November 3rd, which means that next week we will be doing an entire week-long special on SAT math problems where I'm just going to be banging through practice tests, problems, etc., fielding questions. So make sure to tune in every day next week. It'll be sometime in the afternoon, somewhere around 3 or 4 p.m. Eastern time. Each day it'll vary a little bit, but that's the general idea. So it's really cool. It's going to be really exciting. And hopefully you'll get some good prep. And if you haven't seen so yet, make sure to check out my score reveal where I took the SAT and actually revealed it to everybody live on camera. It's pretty fun. It's one of those things too where it was a really tough curve for the October test, whereas it was an easy math section, but a really tight curve. And I actually ended up I went over this on the stream, but I got one question wrong, and which I couldn't believe. It was a medium level question. And just apply the wrong formula, and I misread the problem is what I think happened, and so I got a 790. Still, pretty good performance, but I'm always obviously shooting for 800 when I take it. Anyways, without further ado, let's jump into the next section, which is linear function word problems. So let's do it. Okay, hold on. Let's see. Nope. 125. There we go. All right. Question number 1. Gustav is starting a special sprinting regimen in outdoor track. The regimen suggests sprinting for a certain number of seconds at seconds. The second time he sprints, he should run 150 more than the first time. For the third time, the regimen suggests sprinting twice the number of seconds as the first time. Okay. So I'm just as I'm reading, I'm mapping these out in little expressions. Finally, the regimen suggests an 80-second sprint. Which of the following functions can be used to find the total number of seconds t suggested by the entire sprint? It's all of these added together. So it's s, 2s, 4s plus 150. I mean, sorry, not 150, plus 230. Read this guy. All right, cool. Next. 2007, approximately 50% of the world's population lived in rural areas. From 2005 to 2000, I'm just going to write 50%. Then it goes decreased by 0.5 percentage points each year. Wait. So it's saying 50%. Oh, so it already started. This is in 2007. It's saying 2005 here, and then this is 2013. So it already dropped by 0.5 percentage points per year. So we could say 2005, it was likely at 51%. If t represents years since 2005, which of the following equations best models this guy? All right. So, these are not nice equations. So we're gonna have to think about this a little carefully. Now, all right. So it's kind of like t. Every time we're hitting t, we're multiplying by 0.5. Actually, we're dropping by 0.5, and that's kind of like the slope, right, per year. And I see that on most of these, it's negative 0.5 multiplying the t. So that's all good. Now, let me see. And then R is the percent. Okay, got it. So I can think about it like this. I can say that R equals. I'm going to show you how I'm going to kind of reverse engineer this. I think I have an idea of which one it is. I think it's going to be. Well, let's actually go through it. I have a feeling it's going to be A, because that seems like it makes sense in terms of if I isolated R, because I'm going to show you what happens when I'm going to set it up my way. So my R, that value equals, and we got a couple values here, right? We've got when t equals, if I say that t equals 0, right, here at 2005, here t equals 2, okay? And if I say that, and which means that my y-intercept is actually 51, and my slope is negative 0.5, T. Okay. This would actually be my equation in what we call slope-intercept form, because I'm starting at time 0 at 51, and and this is my slope. It's dropping by 0.5% every year since then. Okay, now we need to kind of reverse engineer it into one of these equations. Now, you notice what they do is, I mean, this is, oh, I see what this is. This is in point slope form. Never mind. Okay, I can get this to A, but let me show you what they did in point slope. What they did is they chose the coordinate 52, like 2 years after at 50%. So they said R minus the Y value, which is 50, which is the percentage, equals negative slope 0.5 times T minus 2. And this is the year that corresponds with 50 is 2, so that's why it kind of goes here. And if you remember, point slope is y minus y1 equals m times x minus x1. So they threw on an extra level of complexity. This is the answer, but it's also the same as this. This is just slope-intercept. This is point slope. So I'm pretty sure it's A. And let's check it out. Yeah. Okay. Next. If you're new to the stream and haven't seen this before, I'm always solving these in real time. I've never seen these problems before. That's part of the fun, and I think that's a lot part of the value as well. You're actually seeing me work it out in real time, if you're wondering. All right, next, a florist orders exactly 1/3 gallons of nutrient-rich water for each bushel of flowers he buys. Okay, so we're getting 1/3 per bushel. The florist buys bushels of flour. Wait, now we're switching to the flowers. So 1 bushel costs $1.20. I'm just going to say equals, but it really costs $1.20. And gallons of, so I'm going to say bushels is $1.20. Gallons is 60 cents. Okay. Which of the following equations gives the total cost? Excuse me. Which of the following equations gives the total cost in dollars for bushels of flour? Okay. So we can say every bushel costs $1.20. But for every bushel, okay, we're also getting, so we're also getting, for every bushel, we're getting 1/3 a gallon, and 1/3 of this, I'm going to say 1/3 at 0.60, just 20 cents. So 1/3 of the cost, whatever this is, same thing per bushel, because we're only having one variable. We can't say gallons. We can't just say 0.6 times gallons. We're trying to, I mean, we could, but we're trying to make this into a 2-variable equation, not a 3-variable equation. So I know they tell us at the beginning that for every bushel, we're getting 1/3 gallons of water, and each gallon costs 60 cents. So 1/3 of each gallon is what I'm representing here. I just know that 1/3 of 60 is 20. So we could represent this as, oh, and see how they've represented it for us. It's like that. So let me further refine this. Hold on. It's 1.2b plus 0.2b, right? 1/3 of 60 is 0.2. And then they factored out the b. And I believe it again looks like it's A. Let me double check. Yeah, it's got to be A. All right, next. A used car dealer would like to cover as many vehicles as possible with 220 liters of paint and 400 liters of clear coat. 220 liters of paint, 400 liters of clear coat. It takes 13 liters of paint and 9 liters of clear coat. This is how much they have total to cover one car. It takes 1.5 times those amounts to cover a truck. This is no calculator section, so this is like 22. All right, so 1.5. See, I can't do this. This isn't great, but 1.5 times this would be 13.5 here. And you know what? I don't think we have to do that math. I feel like it's going to be in the equation. The dealer covered vehicles until no paint was left. Which of the following shows the number of trucks the dealer... okay. All right. As a function of the cars the dealer covered. Shows the number of trucks dealer covered as a function of the cars the dealer covered. This is worded so poorly. I know what they're asking, though. They're asking, essentially, for every car, okay? Hold on. Oh, wait. Did they say paint or clear? The dealer covered as a function. Oh, so I see. No, wait. Never mind. Hold on. Trucks. So they use that 220 times those amounts to cover one truck. So do we need a full hold on. Let me think about this for a second. Ooh, this is tricky because I'm just thrown for a loop here. So none of these even use the clear coat for some reason. I'm trying to figure out why. So hold on. The dealer covered vehicles until no paint was... oh, yeah, that's why. So we're only talking about paint. Paint is the limiting factor. Which of the following shows the number of trucks? So this is my number of trucks, okay? So they're saying 220 is my total. And then we want... this one, hold on, doesn't make exact sense. So we want... minus 13. Hold on, let me think for a second. So that's the number 220. Ooh, I'm kind of tripped up here. So I'm gonna try and construct this myself here instead of looking at what they've got. So it would be like if we did one car. So all right. So if we have 220 minus 13 cars. Hold on a second. 13. Wait, we need to divide this, right? Oh, I'm really confused here because 1320. I'm going to say C is out. I don't even know why we're having this 9 in the mix. I'm going to say C and D don't make any sense because that's bringing in the clear coat, right? You see those 9 values? So it's going to be one of these two, but now I got to reason it through as to why. I like this where it's 1.5 times 13 because that's the actual amount of paint is going to be 1.5 times 13. And then B makes more sense. So why that division of the 13 at the end? Let me see, 213. Why we divide by 13 at the end is not clear to me. So I'm just using my logic here. I'm trying not to take too long in this question, but I think it's B. Let's see, 213. So every one we do there is 1. And hold on, F of C, that's the number of trucks. It's the number of trucks. Oh, I get it. I get it now. I get it. So it's like, so whatever. I get it. I'm changing my mind about this. This is the number of trucks they covered, okay? In terms of, okay, I understand now. So what they're saying is, basically, this is my number of cars that I'm painted, or this is the amount of cars that I'm painted, and then what's left over is what I'm using for the truck. So like here it's this, and then hold on a second. Let me make sure I didn't discount any of these too quickly. So the number of cars, got it. It's this one, it's A. Okay, so look, 13 times 1.5 times this, right? Equals the amount of paint on the trucks. And this equals the difference, this equals whatever we used on the cars, or the what's left over from the cars, which is 220 minus 13C. And then they just divided both sides by 13 times 1.5. So I'm pretty sure that's A. Let's see. Let's go for it. Yeah. Oh man, that was really tricky to understand. Just in full disclosure, when I took the SAT, I didn't see anything that tricky that took that much level of thought. I know a lot of times people ask me, how am I supposed to do that in the time? You will have time for harder questions like this to process and think through and kind of sort of deconstruct it, because I would call this a hard problem. I don't know if anybody agrees with me, but I think this is along the lines of a harder one. You'll usually have a lot more time at the end to really ponder these. There's nothing like this on the last SAT. Okay, next. Final question. Li Yang and Siyu Han are runners. In 1 hour, Li Yang can run 21,000 meters, and Siyu can run 19,000. That's far. That's like 21 kilometers, which is like, yeah, that's a lot. Okay. Both runners are in a race where Sion gets a half-hour head start. Okay. If both runners run at the rates described above, okay, this is 21,000 per hour. This is 19,000 per hour. Which of the following functions give the distance in meters between the runners, T hours, after Li Yang begins? Okay. All right, so this would be, so Li Yang, her distance is 21,000 per hour times T, okay? And we'll say, actually, we'll do it the other way. Hold on. We'll say 19,000, actually 200 times T plus 0.5 minus 21,000 T. Okay. So this is the difference between the two. Now I'm going to distribute this. This is a calculator problem. I'll just do it without. I think it's probably fine. 19,200 T plus half of that is 9,600 minus 21,000 T. Okay. And then we combine these guys. 21,000. It's a negative 21,000, positive 19,200. That gives me 1,800. And again, the absolute value is because we're just taking the distance, so it can't be negative. And again, I think we've got A. All of these seem to have A. I think this is right? I'm just looking at the 10,500, wondering if I missed something. But that would be half of 21,000. But they're not getting the head start. This one's getting the head start. So I think it's A again. Hey, all right, cool. So that is it for the live stream from Scalar Learning today. Now, here's the thing. I've got a vlog video that's coming out this weekend that's all about my entire journey taking the SAT. Everything from what I did that morning to go into the test day, the proper mindset, the drive over, everything I was doing. And then, of course, it ends with the score reveal. So that's going to be coming out this weekend. Make sure to look for that, especially as you're gearing up for the new SAT that's on November 3rd. If you're taking it, make sure to leave a question in the comment section below if you have anything in particular you want me to show you or go over. And tune in next week. Tune in every day if you can. It will be really beneficial for you. I know a lot of people have been watching. Hey, what's up? Yeah, you finally get to see me live. All right, I'm watching now. I'm reading now. Usually I don't, because when I do these streams where I solve problems, kind of boom, 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 I just focus on hitting those problems up. But yeah, if you have a quick question, I actually have to go because this is when my tutoring day begins, so I got to hit the road. But next week I will do my best in between breaks to jump on. Hey, what's up, Fatima? Yeah, nice to see you too. So anyways, for those of you guys who are taking the SAT this week, best of luck, and thank you for jumping on the live stream. I hope you enjoyed it. I hope you found it useful. And that's that. I will see you guys next time. Take it easy.